In this video, we will go through chapter 1 in class exercise 1, that is problem solving based on chapter 1, units and unit conversion. This in-class exercise is at page number 9 of your master handout. Guys, I have brought into Microsoft OneNote notebook, so I will write it here and you can see the solution. Now we will select a sample problem from this in-class exercise and find the solution, and you can apply the similar strategy to other problems. Remember that we have learned that the problem solving strategy is interpret, plan, and execute, IPE. Okay, so problem number 1.4, convert 200 foot-pound to Newton meter. So let's solve this problem. So 200 foot-pound, and we need to convert this into Newton meter. So there are two different units here. So foot, and first we need to convert foot into meters, and we have this table here, conversion table, that 1 foot is 0.3048. So we need to multiply this with 0.3048. That's part one. And then second is to convert pound to newtons, and for that we have to multiply with 4.448. So when we do this multiplication, we get the number 271.16. Remember, we need to round our answers to 3 significant figures. So there are 5 significant figures here, 2, 7, 1, 1 and 6. To round it to 3 significant figures, we will round this as 271 Newton meter. And this is the answer to our first question. In the same way, please apply the solution to other unit conversions. So convert 300 pound-foot cube to kilonewton meter cube, or 8 feet per hour into millimeter per second, and represent answer to 3 significant figures and use an appropriate prefix. So try to solve this yourself, and then compare your answers with the solution which is on Kodiak. In fact, these are also the problems in your homework, so you can actually directly start working on the homework problem and then learn on the way. Problem 1.8 is very similar to 1.12, so we will focus on 1.12 and that to the middle one. So let's read the problem statement. Evaluate each of the following to 3 significant figures and express each answer in SI units using an appropriate prefix. So let's work on it. So 28 millisecond multiplied by 0.0458 megameters. See, it's capital M, so a capital M is for mega, like megabytes, divide by 348 milligram. So we need to first convert each one of the unit into standard units for fundamental physical quantities. So time should be in seconds. So we convert millisecond into second by multiplying with 10 to the power minus 3. Okay, that's step number 1. Step number 2 is we convert 0.0458 into meters by multiplying with 10 to the power 6. So now we have seconds and meters in the numerator. At the denominator we have 348. It's milligram, so we need to multiply this with 10 to the power minus 3 to convert this into gram. But remember that the standard unit for mass is kilogram, so we need to multiply with another 10 to the power minus 3 to convert grams into kilogram. So this is our standard unit, second, kilogram, meter and second for SI system. So next what we need to do is you multiply all these numbers and then also this 10 to the power multipliers. We get that as 3.68 multiplied by 10 to the power 6. Now that's a big number. Since it is 10 to the power 6, we can use appropriate prefix. So we will represent this answer as 3.68 and write that as megameter multiplied by second divided by kilogram. So we have replaced this 10 to the power 6 by mega applied to meter. We could have actually applied this to second as well, but normally for time we do not use like megaseconds. Oftentimes we use second or millisecond for the time, but for distance mega makes more sense. So this is 3.68 megameter into second divided by kilogram. And you can see here that we have only one prefix, no compound prefix, means the other two units are in the base units. They do not have any prefixes. Okay, so that's the solution to problem number 1.12. Problem 116, try to solve it yourself. That is the problem of converting the unit of pressure, like atmospheric pressure, into different units. So for pressure, bar is one of the units, but Newton per meter square is another unit. And there is also this popular unit that we use in day-to-day life is PSI. It is called pound per square inch. Okay, that is this unit. So you will apply the conversion of like 1 Pascal to pound per square inch in problem 1.16. Last problem, problem 1.20. So let's focus on this problem. If a man weighs 155 pounds on the earth, specify his mass in slug, his mass in kilogram, and his weight in newtons. If the man is on the moon, where the acceleration due to gravity is 5.30 feet per second square, determine his weight in pounds and his mass in kilogram. We will only solve the first part of the problem up to here, and the remaining part is the same procedure. The only difference is the gravitational acceleration on the surface of the earth. So g of earth is 9.81 meter per second square, or in FPS system it's 32.2 feet per second square. Okay, and for the moon, where gravity is 1/6 that of earth, so its value is 5.30 compared to like 32.2. Okay. So let's apply this solution to this problem. Number one, weight of the man is given, which is W, 155 pound. The equation that relates weight with mass is W equal to mg. That weight is equal to mass times gravitational acceleration. Now we need to find his mass in slug. So let's substitute value of W in pound. Value of mass, that's what we are calculating. G is 32.2 because the unit is FPS. So if we divide 155 by 32.2 and round it to 3 significant figures, we get 4.81 slug. Okay, so that is the answer to the first question, A. Second, calculate his mass in kilogram. So to convert slug into kilogram, we will make use of this conversion chart. So one slug is 14.52 kilograms. So we basically multiply this number by 14.52. So M in kilogram is equal to M in slug multiplied by 14.59, which is 4.81 multiplied by 14.59, and that is 70.17. Now these are 4 significant figures, so we round it to 3 significant figures. 70 point, because the last digit is 7, which is more than 5, we will increment this number to the next higher number, 2. Okay, and the final answer is 70.2 kilogram. Third question is, what is his weight in newtons? So there are 2 ways we can do that. Either we can multiply this mass with gravitational attraction, that is 32.2, and get the answer in with 9.81, because that is the unit for SI system, and get the answer in Newton. Or we can convert directly this pound into Newton using this conversion chart. So 1 pound is 4.448 Newton. So let's convert W in Newton is equal to W in pound multiplied by 4.448, which is 155 multiplied by 4.448, and that is 689.44. These are 5 significant figures, and if we round it to 3 significant figures, we will round this as 689 only, because this digit is less than 5. If this was 6, we will round this number to 690. But since this is 4, we will round this to 689 Newton.